Hi, welcome back to Moose and Chemistry. This will be Lewis Structures Lesson 6. Today we're going to work two different formulas that we haven't worked before. The first one is going to be SHF, which is kind of a really strange one. Alright, so let's do this one. S is in group 16, so it comes in with 6 valence electrons. H is in group 1, so it comes in with 1 valence electron. And F is in group 17, so it comes in with 7 valence electrons. Alright, so let's total this up and see what we have. So S, we got one of those times 6 electrons. We got H, we have one of those times 1 valence electron. And we have F, we have one of those times 7 valence electrons. So this gives me 7 valence electrons, 1 valence electrons, 6 valence electrons, and that's a total of 14 valence electrons. So S is the center atom. So we're going to put an S in the center. And knowing that we have like 2 extra electrons, here and 2 here, we're going to go ahead and do it like this. And that's going to give us an H. And this is going to give us an F. Now, this is called a AX2E2 bent structure. It has bond angles of approximately 104.5 degrees. We're going to do something a little bit different today. Well, that was a Tom Petty quick break there. Okay, so now let's see here. Okay, let's check out our formal charges for the S first. Formal charge for S. Remember, it's valence electrons minus non-bonding electrons minus bonding electron pairs. So that's going to give me, came in with 6 valence electrons. It has 4 non-bonding electrons, 2 bonding pairs, so that's 0, that's good. The formal charge for H, and we have to do each one here because the H and F are different. Of course, hydrogen had 1 valence electron, there's no non-bonding, minus 1, that's 0, that's good. And the formal charge for fluorine, in this case, of course, let's see here, fluorine came in with 7 valence electrons. It's got 6 non-bonding and 1 bonding, and so that's a 0. That's also good. Let's look at the dipoles. Okay, in this case, the hydrogen's electron is going to float towards the sulfur, so the hydrogen is going to be positive, sulfur is going to be negative. But fluorine is extremely electronegative, so the dipole here is going to float in this direction, where that sulfur free electron is going to head towards fluorine, and sulfur is going to become a little bit positive there. So that negative here and this positive here is going to kind of balance each other out for the sulfur. Okay, and let's see. Oh yes, let's do the hybridization. So sulfur's got 1, 2, 3, 4. So sulfur is sp3. Fluorine is also going to be 1, 2, 3, 4, sp3. And hydrogen is just simply going to be S. So let's look at another one. Okay, so we'll clear these drawings real quickly. And we'll clear all those out. And let's look at a different one that we haven't done. Let's try CF2S. Okay, carbon is in group 14, so it has 4 valence electrons. Fluorine is in group 17, so it has 7 valence electrons. And sulfur is in group 16, it has 6 valence electrons. Okay, so what we're going to do now, carbon, 1 times 4 valence electrons. Fluorine has 2 times 7 valence electrons. And of course, sulfur has 1 times 6 valence electrons. Okay, Well, that looks good so far. Where'd that mark come from? All right. So anyway, getting back to this. So we're going to do this. So this will give me 6 valence electrons, 14 valence electrons, and 4 valence electrons. All right. Okay. So now what we're going to do is we're going to give me 24 valence electrons. So carbon's going to sit in our center. Fluorine's going to be on one side of carbon. Fluorine's going to be on the other side of carbon. And we have to put sulfur here. So we're going to connect all three first. And then we have to make sure each side has an octet. Yeah, wraparounds. Oh, you know what? There's a problem with this structure. Look at this. Carbon only has 6 valence electrons. It must have 8 valence electrons. So what we're going to have to do is we're going to have to take 2 from somewhere. We can't take it from the fluorines. Okay? So we're going to take it from the sulfur. So let's go ahead and erase a couple things here, like the stray mark. And we're going to erase all this right here. Okay, and we're going to fix this pretty darn quickly. And what we're going to do now is we're going to move these 2 dots. Okay, and that's going to affect everything else. So this is going to be this, and now that structure. Okay, let's see what this is going to mean for us, okay? So let's check out the formal charge to make sure this is right. Remember, it's valence electrons minus non-bonding electrons minus bonding electron pairs. Okay, so we come in, carbon comes in with 4 valence electrons. It has 0 non-bonding electrons, and it has 4 bonding pairs. So that's 0. Formal charge for F. F came in with 7 valence electrons, 6 non-bonding electrons, 1 bonding pair. So far that looks great. Formal charge for sulfur. Sulfur came in with 6 valence electrons, 4 non-bonding electrons, and 2 bonding pairs. So that gives me 0 also. That looks great. This looks really great. This is going to be an AX3, which we call a trigonal planar. Let's get that spelled a little bit better. I messed up when I was writing. I'm sorry about that. Scientists, anyway, we don't spell very well. We leave that to the English people. All right, so now let's see here. So let's see what the hybridization for carbon is. Remember that the double bonds, there's a 1 sigma bond. One of these are sigma, and the other one has to be pi, right? So that would give me 1, 2, 3. So that would give me sp2. The fluorine would give me sp3. And the sulfur would be 1, 2, 3. So the sulfur would be sp2. All right. And by the way, the bond angles, of course, are 120 degrees for this one. And you guys have an awesome day. And we look forward to seeing you again at Moose in Chemistry.